I'm from ECE 1 of the La Salle University Dasmariñas, and today for my digital electronics 2 subject, I'm going to do experiment 1 entitled Digital Output.
For experiment 1 in our digital electronics 2 subject, it is entitled Digital Output. So our objectives are number 1, to learn how to create a project and build a project. Number 2, to understand how the final code programmed to the microcontroller. 3, to create a simple code for controlling an LED. The equipments and components used. First is a PIC16F18875 microchip, a 220 ohm resistor, an LED, a breadboard, connecting wire, PKIT 3, and a power supply. Now let's start to do the experiment. So click on Start, type MPLAB, and click on this application, MPLAB XIDE, and wait for the application to open, and then this should appear. And at the home screen, what we will do is click on File, New Project, and Microchip Embedded and Standalone Project, and next we will change this device to the model of the IC, which is a PIC16F18875, and then click here and next, and click on XC8 and next, and name your project Hoya underscore experiment 1. After that, we're going to click finish and wait for the application to load. And after a while, this home screen will appear, and here we should click on window, MPLAB code configurator, and then wait for the application to load. And just save this. Keep in mind where you saved it though. And then here, these are the resources, but first we're going to modify the system module. Here in the system module, go here and click on this one, the output, and then after that we should change the name of the LED. So this custom name, we should change this to LED underscore T2, and then untap this, and in the system module we should make sure that oscillator is selected to this, internal clock is 4 megahertz, and clock divider is 4, and this one is checked. After that, what we should do is click on generate, wait for the application to load, and then after a while generation is complete. Next step is to click on projects, open source files and this main.c file, and scroll down and add the application code here. So underscore delay, underscore ms, and 250 millisecond, and enter, colon, and enter, and then LED underscore D2, the name of our LED that we changed earlier, underscore toggle, open close parentheses, and then we're good to go for the code. After this, click on here the build button, and again wait for the simulation to load. And wait for there, build successful, and loading completed. After that, what we should do now is to connect the PicKit to our computer. So this is the PicKit 3. This is the microchip that we're going to use to program the hex file into our IC later. So first, here are the connectors. This one should go here, and the other one should go in the USB port of your laptop or PC. So as you can see here, there are 3 labels in the PicKit. Power, this will turn on green. Power is being supplied to the PicKit when connected to the PC. The active will turn on blue color if it is connected to the PC USB port and the communication link is active. And the status, there are 3 colors: green for success, orange for busy, and red for error. And now, if we are to connect the pins in our PicKit, as you can see, there are 6 pins that can be inserted here. So the first pin is the MCLR or VPP. And it goes here. And then the second pin is the video target. The third pin is the VSS or the ground here. And the fourth pin is the PGD or the ICSPD80 for the data. And the fifth pin is PGC ICSP for the clock CLK. And the sixth is the PGM LVP. So here's our PicKit, and now this should be connected to the circuit so we can program the IC. And now we should connect the PicKit pins to the IC so we can program the IC. So let's go. This should be the connection when we are to program the hex file into the IC. After connecting the PicKit 3 to the computer, we should click on Start and open MPLAB XIPE to wait for the application to load. Once the application opened, what we're going to do here in this application is to change we should select tool PicKit, this one. When it's connected, that should appear. And this is already PicKit. We can now click connect. Wait for the application to connect to the PicKit, and then just click OK here. Okay. then wait for the connection, still loading, and this error will always appear because we need to edit the settings. Advanced mode password is microchip, and here is where we will edit the power in terms of the PICkit that we have. In our case, it should be 3.125, and power target circuit from PICkit 3 should be checked there, so we can remove the error. So now we click on operate and then browse for the file that we made earlier. So in my case, it was saved here, and here, and here, production, and here's the hex file. That's the one, that's the code that we're going to use. And then it was loaded successfully, and we click program. After that, just click OK here, and another OK here, and then wait for the program to program the microchip. Wait for the application rather to program the microchip. And as I scroll down there, you can see that programming is complete. After that, we're good to go to check if our program is working. So here we are to connect the circuit so we can check if the code is working. So for the circuit, pin 6 should be connected to a resistor for us to see the output. This is the output side, so we're going to put a resistor here and an LED, and of course ground to that LED. And then what we're going to do next is to put a connection here at pin 11 and put that to the source, and another one is pin 32 and again to the positive source, and also the VSS and the VSS pin 31 to the negative side. After that, connect the positive and negative terminal for the power supply and turning on, plugging it in. After plugging it in, the LED is observed to light up for 250 milliseconds. It can be observed that the program worked, or the code worked. It was successfully programmed into the IC. The next part of the experiment is to do a code that would turn on, the LED would turn on for 2 seconds and off for 2 seconds. So to do that, just change this to 2000 and then build, and then wait for the code to be completed, the hex file, and then here the build was successfully done. We can now transfer that to the IC using the PICkit and using the connection that we used earlier. So it's the same. We're going to use the pin connection that we used earlier for us to transfer the 2-second code to the IC using the PICkit. The same procedure as in the part 1 of the experiment. We should browse for the hex file for the 2-second interval of on, and here is the hex file. Click on it, and then we should connect this, pick it, wait for it to connect, and then click OK, just like what we did last time in the part 1. Wait for the simulation. Again, this we're going to solve it through settings. Advanced mode, microchip is the password, and then after that, here again 3.125, and then here overall good, and then select program. Click OK, and then wait. OK, and then programming complete, and then we should now test this in the kit itself if the code really changed from 250 millisecond to 2-second intervals. After constructing the circuit, let's try. And we just plug the power supply, and there it is, 2 seconds. 1, 2, 1, 2, 1, 2, 1, 2.
Using the applications MPLAB XIDE and MPLAB XITE, the programming of the code of the hex file to the IC was possible. It can be concluded that the IC can be programmed in any manner depending on the code. Using the IC PIC1618-875, LEDs was programmed to turn on and off for 250 milliseconds and 2 seconds. An application that can be related in this experiment are light signals for alarms or Christmas lights. In doing the experiment, it is important to have a background knowledge on the pins and configurations of the materials and equipment used. Also, it is essential to have an understanding how to code and program using the applications MPLAB XIDE and MPLAB XITE.